Hey guys, what's up? Welcome back. In today's video, we'll be looking at how quadratics show up in real life. We're going to look at examples to see how this powerful mathematical tool helps us in physics and engineering, business and finance, and architecture and design. Let's get started. So first of all, I'm going to start with a function here. This is going to be a height function. It's going to model the height of a soccer ball after it is kicked. So t squared plus 14t plus 1.2. And our goal is to find the maximum height that the soccer ball reaches. Okay, so to do that, the first thing we have to look at is, okay, so this is the function, and we're just trying to find the maximum value of it. Because this is a quadratic that opens downward, um, means the graph is going to look like this. That means the vertex, which is like roughly here, that's going to be your maximum height. And so remember that to find the vertex of, to find like the x coordinate of the vertex, we have to do negative b over 2a. And so here, that equals to negative 14 over negative 9.8. This simplifies to 14 over 9.8, which is roughly 1.43 seconds. So now we know that the maximum height of the soccer ball occurs at 1.43 seconds. So to find the actual maximum height of the soccer ball, we have to do h of 1.43 is just if you have a calculator handy or something, now would be the time to use that. And this roughly turns out to be 11.2 meters, or whatever units that you're trying to use. So yeah, pretty simple here. Yeah. All right, so now it's time for an example of business and finance. A store sells headphones for $60 each and sells 100 per month. For every $1 decrease in price, two more are sold. What is the price that maximizes the revenue? Okay, so a couple things to note. One, the problem gives us information about the price and the quantity of headphones, and it asks us about revenue. And so it's important to note that revenue is indeed equal to the price of the product times the quantity sold. Okay, and so now we are given information that there will be like $1 increases in the price. So just for simplicity's sake, we're gonna set x equal to every $1 decrease. And so what this does is it allows us to write the price as 60 minus x and the quantity as 100 plus 2x, because for every $1 decrease, there are two more headphones sold. Okay, so now we can write our revenue function as revenue is equal to 60 minus x times 100 plus 2x. Okay, so now we're just trying to find the price that is able to maximize the revenue. And so to maximize the revenue, first we're just going to expand out the right-hand side, and we're going to get 6,000 plus 120x minus 100x minus 2x squared. This can be rewritten as minus 2x squared plus 20x plus 6,000. Okay, and as we can see, we have a quadratic here, and we're just trying to maximize the revenue. And so once again, we're going to use our formula from before, the negative b over 2a, to get negative b over 2a is equal to negative 20 over negative 4, which is equal to 5. So basically, whenever x equals 5, that's when the revenue is maximized. And so since x represents the $1 decreases, whenever the price decreases by $5, that's when the revenue is going to be maximized, and that is going to occur at $55. Okay, for this example, this is going to be an example of using quadratics in architecture. And so here we have an arch that is modeled by the function y equals negative 0.25 x squared plus 4, where x is represents the width and y represents the height. And so what is the width of the arch at ground level? Okay, since y represents the height, at ground level, y is just going to be 0. And so we're going to have 0 is equal to negative 0.25 x squared plus 4. And so now from here, since x represents the width, basically we're just trying to solve for x. And it looks like it's pretty simple to do from here. Just do this 4 is equal to minus 0.25 x squared. Um, then x squared is equal to minus 4 over minus 0.25, which is equal to 4 over 1/4, which is equal to 16. And so x is equal to plus or minus square root of 16 equals plus or minus 4. And obviously we're going to go with positive 4 because a width or any measurement of any type can't necessarily be negative. And also we would put units, whatever units the problem would give us. So yeah, this problem was relatively straightforward. Just the main thing is we just have to interpret everything within the context of the problem that is given to us. And a lot of times, whenever we're dealing with measurements, we don't want to go negative. All right, now we have another example from physics. A ball is dropped from a 20-meter height, modeled by h of t is equal to negative 5 t squared plus 20, where t represents the time. When does this ball hit the ground? Okay, so since we were given the function for height, um, when it hits the ground, the height is going to be 0. And so we're just going to have 0 is equal to minus 5 t squared plus 20. Okay, now it's pretty simple from here. We just kind of do something very similar to the other problem because we're just trying to find the time at which this is true. And so we're just going to do negative 5 t squared is equal to negative 20. T squared is equal to 4. And t is equal to plus or minus 2. And since time can't be negative, we will just have 2 units of time. Most likely going to be something along the lines of seconds. All right, that's kind of it for all the examples. Just a few key tips to remember for whenever you're using quadratics for real-world applications. You always want to understand what each unit or variable in the quadratic means and represents. Solving the quadratic is one thing, but getting the right answer and interpreting the situation in context is another. And that usually is the most challenging or like important part. You always want to know like what you're trying to solve for. You don't just want to like jump into the problem, you know, before doing all that. And yeah, that's kind of it for this video. It was kind of short. If you thought it was helpful, feel free to drop a like and subscribe for some more math tips coming your way.